All right, before we talk really in depth about what a z-score is, because it's really important for this class, I want to talk about what happens when you find a z-score, and specifically what happens to the shape, the center, and the variability, the spread, when you're finding a z-score. And the reason I want to do this is because we're going to use z-scores all the time. And so it's important to know how you're manipulating your original graph when you're doing things, value minus mean over standard deviation. We're doing some subtraction, which we'll talk about here. We're doing some division, which we'll talk about down here. So before we really talk about what a z-score is, if you're not 100% sure what a z-score is, why we're learning about it, just hang tight with me for a second, because before we get there, I really want to talk about what is happening here when we find z-scores. Go ahead and put the date at the top of your paper, and let's get started. All right, when we're finding a z-score, the first thing that we do is we take each score and subtract the mean. Remember that the mean was 80. We're still talking about our quiz score, our chapter 1 quiz with our Harry Potter characters over on the other page. So what I want you to do is pause the video and just go ahead and fill in the table. So you'll need to subtract off the mean from each of these numbers, and then go ahead and put a dot plot of all the scores. That'll be this part, and then a dot plot of the second part, which is the score minus the mean. I know these numbers don't exactly match the lines. Just do the best you can so you can see the general shape. All right, so again, the lines don't really match up. I should probably just change these graphs. I tried to make it a little bit better, but I don't know, maybe I made it worse. The point is that you can kind of see a general shape, a general center, and a general spread when you're looking at these two things. So again, let's talk about this. What's happening when we look at the shape? If I look at the shape here compared to the shape here, they're exactly the same. The scale has changed, but the shapes are exactly the same. All right, what about the center? So the center over here is about at 80. The center over here is at 0. So we have 80 versus 0. Okay. What about the spread, the variability? So let's maybe talk about range for this one. Let's see what the range is. So for the range of the first one, I'm going to take 99 minus 61, and that's equal to 38. For the range of the second one, I'll take 19 minus a negative 19. I still get 38. The range has not changed. The variability, the spread has not changed. All right, so this one's the same. This one changed. That one's the same. Okay. So the shape is the same. The center did change, and the variability, the spread stayed the same. Okay, keep those in mind. Let's move on to the division. So after we take score minus mean, we're going to divide by the standard deviation. And the standard deviation, if you remember, is 10. So let's go ahead and fill out the table here. Now, I don't know what happened here. I didn't put the little lines, so it was here, and somehow in my printed version, it's not. So you'll just have to maybe use the same thing here and maybe make it go from -2 to +2. Okay, with 0 in the middle. Okay. So go ahead and pause the video, fill this in, and then let's throw it on your dot plot. Okay, so I've got my division in here. I made a general brief outline of my dot plot. Again, just enough so that we can see the shape, the center, and the spread, the variability. So let's talk about what's happening here. The shape, again, it is exactly the same. And I realized up here I wrote shape and not same, so I am going to go ahead and fix that. So the shape is the same. And I mean, the scale is different again, but the overall shape of it is the same. The center looks the same as this guy right here. The center looks like it's 0. But if you think about what's happening, we've actually taken 0 and divided it by 10. So the center, we technically divided by 10. You just can't see it because it was a 0 to begin with. So the center was divided by 10. The variability is, let's see, we have 1.9 minus negative 1.9, which is 3.8, which is 38 divided by 10. So again, we've divided our variability by 10 as well. Okay, we've made it a little bit smaller. Let's summarize. When you are given a list of data, any list of data, not specifically talking about z-scores, and you add or subtract the same value from each value in the data, the shape is going to stay the same, and the variability is going to stay the same. Let's look at our rule up here. We subtracted 80. We subtract 80 to get to 0. So when you want to find your new center of your data, you are going to add or subtract A. Whatever your value was, A. Okay. Here we're going to talk about taking one step further. So when you multiply or divide, again, the shape stays the same. Your center, we divided by 10. That was the value. We divided by the standard deviation of 10. So here you're going to multiply or divide by the value. Same thing with the variability. We're going to divide by our value. All right, so I'm going to put a little star, a little box around this. Anytime we are manipulating our data, these are the things that happen to it. Okay, it's called a transformation of your data. And these rules will stay the same regardless of what value you're adding or subtracting by and what value you're multiplying or dividing by. Let's bring it back to z-scores just for 1 minute before we get into the nitty-gritty of z-scores kind of on the next pages here. When we looked at the original, the Chapter 1 quiz scores, I'm going to start at the next page here. So when I looked at the original Chapter 1 quiz scores, they had a mean of 80 and a standard deviation of 10. Once I standardized my data, so once I took a z-score, essentially, we're looking down here after all the z-scores are done, your new mean was 0. And our new standard deviation is 1. We did not calculate that out, but I'll tell you the new standard deviation is 1. So anytime we have a z-score, this is going to be true. You're going to standardize it so that your mean is 0 and your standard deviation is 1. Again, we'll talk more about this when we dive deep into z-scores. Okay? We're going to do example 15 in class together. So this is the end of that video, and I hope you learned something new today.